Good morning, dear students. Hope you are doing well. As we are in treatment of water, hope you understood the concept of this water treatment, why the treatment is needed, and what are the different steps in the treatment. You may understood by following all these sessions. See here, this is about the rough or else partial view of treatment plan. Now you may understood how much of land is required to construct these treatment plants. These type of treatment plants are not only required in water supply engineering, but also they are required in almost the industries where the effluents will be released. By name, effluent treatment plants, and of course there is another treatment plant, that is sea-based treatment plants. This is water treatment plant. We will discuss in detail about this treatment works. See, when you have a look in the topic, what we were discussed after we started the topics or started the part or started the discussion on this treatment. See here, when we back to the topics, there is a topic by name flow chart of treatment works. See, we have seen intakes, which is already completed. Plain sedimentation is completed. Sedimentation with coagulation also completed. Now we are here. Filtration. In filtration, we were finished about slow sand filters. Now we are at rapid sand filters. Am I right? See here, in the rapid sand filters, we have seen the first part and we are at second part, that is backwash of filter bed. See here, backwash of water. See, have a look. This is the wash water tank. Compressed air sending tube. Where it is compressed air? This is compressed air sending pipe. This is the cross section of rapid sand filter. Understand? See here, through this pipe, the compressed air will be sent into the media as it is immersed in the media or is immersed in the bed, filter bed. See here, as the compressed air is sending to the bed, the voids of the sand granules will be released, or else the blocked voids of the sand granules will be released. Why the voids are blocked? Why the voids are blocked? See here, back to see here, we have seen the sedimentation. While the water is passing through the sand bed, after a period of time, the voids between the granules will be closed and they act as settling basins for sedimentation. Why they will be closed? Because of the contaminants of the water, the small voids in between the granules will be closed. Now you understood why the voids will be closed. Why sending this compressed air through this pipe, the voids in between the sand granules will be released. And the precautionary step is here, the sand bed may clogged by dirt, clay, silt, etc., which should be removed to continue the process. Understand? To remove the clogged material, there must be a proper planning and design without any disturbance to the working process to the unit. See here, at the time of washing filters, all the valves shown in the figure should be closed. What is third point? I just discussed about the first point. Why the voids will be clogged? Because of the dirt, clay, slit, or any organic material that presents in the water, and that should be removed. Then only the process will continue. And while we are removing those substances from the voids, we must have proper planning and design without any disturbance to the plant. See here, before we are starting this backwash, all the walls must be closed. Where are the walls here? 1A, wall B, wall C, wall D, wall E, and here two more walls. Let me name them as A, B, C, D, E, F, and G walls. See here, on all the walls are closed. Compressed air is blown off into the beds, which agitate sand bed. Agitation, mechanical stirring, agitation, as mechanical agitate sand bed with stirring by removing the clogged material into the voids of sand. Just while we are blowing sand, we are just agitating the sand granules. By doing so, the blockages of the void, the blockages in the voids will be released. Before we are sending that air, this is the top point. All the removed particles are mixed with the water from backwash tank enters into the sand bed through valve C. See here, from this wash water sand, after compressed air is blown off, all the walls will be closed except C. The water enters through valve C into the sand bed. This is already agitated. The sand bed is already agitated. The voids are released because of the water that enters from the wash water tank with the help of valve C. All the removed dirt slit will be mixed with water. That is what I wrote out there. All the removed particles. Why they removed? How they removed? By sending compressed air. All the removed particles are mixed with water from backwash tank enters into the sand bed through valve C. Hope you understood. Next, at this point, as the valve B is opened slowly, the wash water drained off from the chamber. See, slowly, valve B will be released. So now, see, valve A is closed. After sending required amount of water, valve C also closed. See, as the water enters into this chamber, already dirt and slit, other clay and impurities between the voids of the granules are released because of the action of compressed air, and they are mixed with water, and the same water, as the valve B is opened slowly, and it will be taken off through or else into the drain. Understand? That's what you wrote over there. See, that's what I mentioned over there. Valve B. This process will be continued till the sand bed appears white color. How long the process will continue? Till the sand bed appears white color. Preferably for every 24 hours, about 10 minutes is required for backwashing, where the sand bed expands about 50%. That means expand in the sense the clogs will be released. This is about the backwash of filter. Understand? Now, rapid sand filters construction. These are used to carry out an open rectangular tank with a depth of 2.5 meters to 3.5 meters in an area of 10 meters square to 80 meters square. The bottom layer is made up by gravel about 40 mm within a small, in there itself, the size of the gravel is 40 mm, and in that the smallest size of the gravel is 3 mm, and the entire this gravel structure is made up of with 10 to 15 centimeter to 60 to 90 centimeter of total thickness. as an individual layers. And the top of the sand bed granule size is 0.35 mm to 0.5 mm, which is all which exists on the gravel bed. See why the gravel bed is it is just acting to to distribute water uniformly on the sand, and as well as it is also helping just to inhibit the entry of sand into the bottom of the tank. If the sand enters to the bottom, the underground pipelines may be damaged. The purpose of gravel is, the first one is to, for uniform distribution of water on the top of the sand bed. And the second one is the gravel inhibits the passage of sand granules into the bottom side or else to the bottom of the tank where the underground pipelines are there. Because of the sand entry, the pipelines may be damaged. Understand? And this is the structure. Through inlet, the flow is regulated by inlet and wall, and through inlet, the water will be distributed on the sand uniformly, and water passes through the fine sand, coarse sand, and pebbles. At the end, the outlet pipe is there, filter water collecting GI pipe. It takes the filter water and will be distributed for further requirements. And this is the wastewater valve flow, and this is the compressed air arrangement pipe which is immersed in the filter bed. See here, the whole structure is supported on the concrete bed, and this is the backwash of filter. Whereas in the slow sand filters, we have seen 2 to 3 centimeters of the sand has to be replaced, and then that should be washed and dried washed and dried, and the same will be replaced in the the bed. Else that after taking off 2 to 3 centimeters of sand, that's the gap will be fixed with either new sand or the same sand after drying and washing for the efficiency of sand bed. Whereas here there is no such type of removal of sand, simply as the whole bed is made up of the layers made up in the form of layers of fine sand, coarse sand, and pebbles. There is an arrangement to send compressed air which is immersed in the layers of the bed. Simply, the compressed air will be blown out by removing keeping all the walls in a closed mode. Once the voids are released because of the action of compressed air, slowly or else by opening valve C, water enters from wash water tank to filter media. See, after a period of time, the valve C will be closed and B will be released slowly as the water is mixed with the removed particles from the voids of the granules or sand bed, and the same water will be drained off by keeping valve B slowly, or else by opening valve B slowly. This is about the backwash of filter. And see, the whole process can be carried out for every 24 hours, about 10 minutes, where the soil sand bed may expand up to 50%, and the process will continue till the sand bed appears white color, most probably. That means, which gives the information about the removal of voids of sand bed. This is about the rapid sand filters. See here, when we have a look here, the filtration we have seen. Before that, we'll look what are the steps in this treatment, major steps. Sedimentation. See, we have seen plain sedimentation, coagulation, and filtration. We'll move to the next stage, water softening, that we'll discuss one after one. Have a look this design of sedimentation. Hope you understood about the principles of sedimentation. Principle of sedimentation followed by design of sedimentation tank. Here we have seen an inlet zone, design of settling zone, and design of sludge zone, design of outlet zone. Here one more issue is here design aspects of sedimentation tanks. See, here I would like to stress over here design aspects of sedimentation tank, what we must consider, or what are all the different aspects to be considered while we are going for designing sedimentation tanks. The first one is velocity of flow. This is the associated part of sedimentation. Now we are going to discuss velocity of flow. See here, the velocity of flow of water in the sedimentation tank should be sufficient enough, which may allow the weighted particles to settle at the bottom. If the velocity of water is high, the weighted particles may not settle. That is the reason the velocity of flow of water in sedimentation tank should be sufficient enough to cause the hydraulic subsidence of suspended impurities. It should remain uniform throughout the tank, and it is generally not allowed. See, what I'm speaking is here, the velocity of flow within the sedimentation tank must be reasonable and must be acceptable and must be considerable. Because of what? That is because of that velocity, the weighted particles can be settled slowly, and the velocity should not exceed 150 mm to 300 mm per minute. Understand? This is about the one more aspect you must remember about velocity of flow. Next one is capacity of tank. How can you find out capacity of tank is calculated by two aspects. First one, by considering two parameters. One is detention period. What is detention period here? See, have a look over there. The theoretical time taken by a particle of water to pass between entry and exit of settling tank is known as the detention period. The particle, or as the time that has taken by a particle of water to pass from entry to exit. The time, what is the period time here? The time that has taken to a particle of water, particle is impurity, water, from the entry to exit of a settling tank is known as detention period. One more time. What is detention period here? The time that has taken for a particle of water that is crossing or is that pass between the entry to exit of a settling tank is known as detention period. The capacity of tank is normally the capacity of tank is determined C equal to Q into T, where C is equal capacity of the tank, Q is discharge of rate of flow, T is detention period in hours. How we can calculate capacity of tank? By number one, detention period. What is detention period? The time that has taken to a particle of water for passing from the entry to exit of a settling tank. C, and the C is calculated with the formula Q into T. C is capacity of tank. How you can find out? Q into T. Q means discharge of rate of flow, velocity of flow, or is discharge or rate of flow, detention period in hours. Next one is the detention. Next point is look over here. The detention period depends on the quality of suspended impurities present in the water. For plain sedimentation tank, the detention period is found vary from 4 to 8 hours. See here, the time that has taken to the particle which is crossing from entry to exit of settling tank, we have discussed as a detention period. The time is depends on the quality of impurities. That I said the detention period, time that has taken to a particle of water. Now the detention period depends on the quality of that particular impurities present in water. Normally for plain sedimentation tank, the detention period is found to vary from 4 to 8 hours. Now next one is overflow rate. See, capacity of tank is calculated by detention period. Formula for capacity of tank Q into T. Discharge of rate of flow and detention period in hours. We'll discuss, we may encounter with problems. We'll discuss the problems, okay, in the days to come. Okay, we'll learn the problems also in this sedimentation. See, next is overflow rate. See, in this method, it is assumed the settling of particle at the bottom of the settlement of a particle, the bottom of the tank does not depend on the depth of the tank and depend on the surface area of the tank. The settlement of the tank, see here, assumed in this method, it is assumed that what is assumed? The settlement of particle at the bottom of the settlement tank is not depends on the depth of the tank, but depends on the surface area of the tank. Area. It's not depend on the depth. It depends on the area of the tank. Detention period we learn. What is detention period? The time that has taken for a particle of water when it is crossing from the entry to exit on the settling tank, as we discussed as detention period. The time that has taken a particle, the time also depends on the quality of particle. See a detention period T equaled distance of descent by velocity of descent. See, have a look, detention period. There we have seen C capacity. Now, whatever I said that, see in the formula, detention period T equaled d by v. D means distance of descent, velocity of descent. But T equaled C by Q. T equaled C by Q. See from this formula, C by Q, 2. This is 1. See here, it is 1. And but T equaled C by Q. What is here? Capacity of tank by discharge rate of flow. From equation 1 and 2. From equation 1 and 2. See, this is C by Q equal D by V. Hope you understood how we can do it and how we can get this surface flow over rate. Simply, we are just substituting C by Q equal D by V, where surface flow rate of V equal, simply we are just substituting D into Q by C here, C, and D into Q equal by L into length into breadth into depth equal to Q by L into V. Hope you understood. Just derivation, hope you understood. Nothing is there here. See here, T equal to C by Q from 1 and 2 equation. C by Q equal D by V. Surface overflow rate V equal T into Q by C. Y D, C here, D into Q by C. And simply C means capacity of tank, length, breadth, and depth. C here, Q by L into V. Understand? Length of the tank, capacity of tank, detention period, discharge of rate of flow, velocity of descent of particle to the bottom of the tank. See here, design aspects of sedimentation tanks. We must remember velocity of flow, capacity of tank, and all these inlets and shapes of tanks we have seen. Inlets and outlets arrangements we have seen. This is the outlet and it is the different models of inlets we have seen. And other miscellaneous consideration we will discuss. See here, see in the sense, have a look here about the sedimentation, principle of sedimentation, design of sedimentation tank. In that, inlet, settlement zone, sludge zone, outlet zone, and the other aspects to be considered, velocity of flow. They see we are going to do some problems in this unit about this detention, which may where we may encounter these detention periods and overflow rates and these formulas. Okay, hope you understood. If you have any doubts, you please contact me in the domain, whatever you feel convenient, either phone, message, or mail. Thank you.